Hello, am I audible? Hello, Wilson.
So
Where is your other friends?
I don't know, sir. Okay, let me join the group.
Okay. Okay, so in your previous class, we have discussed about your traffic speed and representation of the traffic speed data. So in this class, we'll discuss about the intersection design. So basically, whenever we are talking about the term intersection, in that case, intersection basically means a section of the road where two or more roads meet at that particular point. Okay. Now, this road intersection is where two or more roads meet and at the points of potential vehicle conflict. Okay, they are the potential vehicle conflict zone. Why? Because there are different roads which are intersecting at a particular point, and there are vehicles which are coming from different directions. Now, they are critical element of road section. Why? Because they enable the road user to change the road path. Okay. Now, they are normally a major bottleneck of to smooth flow of traffic and major accident spot. Now, bottleneck. What is that bottleneck? So, literally, if you are talking about the bottleneck, in that case, bottleneck is basically this type of things. Okay, suppose this is a bottle and this portion is a bottleneck. Okay, now what is this relationship of this bottleneck with the traffic engineering? Basically, what happens whenever, suppose this is a road, this portion is a road is there, and suppose one intersection is over there. Now, whenever that vehicles are coming from different direction, before approaching the intersection, the speed of all the vehicles will be more. Okay, there will be less congestions. Okay, now whenever they approach this section, in that case, what will happen? Their speed would be tremendously decreased. Okay, so if we draw their speed parameters in a graphical form, in that case it would be looking like that. Initially their speed would be higher, but gradually it would be lower. Initially their speed would be higher and gradually it would be lower, like that. So these are the speed of different type of vehicles. Okay, so in the intersection, all these type of vehicles, because of their reduced speed, would act as a bottleneck in the intersection. Now, whenever they crosses that intersection, in that case, what will happen? So initially, for a particular moment, that bottleneck portion exists over there, but as the congestion will be cleared, after that this bottleneck portion would also be cleared, like that. Okay, so this is basically a bottleneck. So this portion is basically bottleneck which occurs in the intersection area. Now, the objective of the intersection design is to regulate traffic operation and ensure safety of the road users and to maintain design speed and maximize the capacity of the intersection. So, as you know, in the intersection area, there are chances of traffic congestion. So, therefore, as a traffic engineer or as a civil engineer, your main job would be to design that intersection in such a way so that the vehicle conflict would be minimum, so that the rate of accident is minimized. And another thing is the speed of the vehicle should be maintained so that there would not be major congestions over this intersection area. Now there are different guiding principle. Guiding principle means the different factors which affect the intersection design. So first one is human factors. So human factors is very much important because all the vehicles are driven by the human us, and we have different psychological and physical characteristics which affect our driving. Okay, so accommodate reasonable road user characteristics. For example, design should follow proper geometric layout so that hazardous movements by drivers are eliminated. So whenever you are designing the road, you always have to think about different hazardous conditions which may appear because of the faulty driving. Okay, so therefore you need to enforce different geometric features over the intersection area. So for example, you know about the side distance. Stopping side distance is very much required to avoid any head-on collision. So therefore you can design the intersection in such a way that each and every point of the intersection, that stopping side distance is there. The next point is traffic consideration. Now, this is very much important because of the traffic considerations. You have to design your intersection in considering the traffic considerations. So, if there are more number of traffic or more number of vehicles, in such cases, some type of intersection may be suitable. If there are less number of traffic, in that case, other type of intersection may be suitable. So based on the traffic consideration, we have to design the intersection. Then minimize the number of conflict points by separating some of the crossing, merging, and diverging conflict. Now, what are these conflicts? Crossing conflict, merging conflict, and diverging conflict. Let us discuss this. Okay, suppose this is a major highway. Okay, and this is the profile of a vehicle moving in that highway. Okay, now suppose there are another road which meet with that highway. Now all the vehicles will be meeting with that existing traffic light. Okay, so this type of conflict is called merging conflict. Okay, now suppose there are another road, okay, which will be going in that direction, and some vehicles will move from the major traffic to that road. Okay, so this conflict, here one conflict zone would be there. This conflict is called diverging conflict. Okay, now suppose another vehicle is coming in that direction and it will merge with the traffic. Now, this type of conflict is called head-on collision, and if it crosses over there, this type of conflict is called crossing conflict. So these are the different type of conflicts which may be occur in the intersection area. So our primary aim for the intersection design is to reduce the number of crossing conflict. Okay, so that head-on collisions and other type of severe accident may be averted. Now, functional intersection area. So, in the intersection area, that is the main intersection area, you have to provide adequate space at the junction so that the speed parameters of the vehicles will not reduce. Now, coming to the next point, types of intersection. So there are different type of intersections. So primarily the intersections are divided into two groups. One is at grade intersection and another one is grade separated intersection. At grade intersection is those intersections which meet at a same elevation. Suppose there are different roads which will meet at same elevation. Suppose for rotary intersection, or suppose your Narengi-Tiniali, that all these type of intersections are at grade intersection. Now another type of intersection is grade separated intersections, where different type of roads will meet at different elevations. So for example, your 6 mile, in the 6 mile area, there are your overbridge is there, Okay, so this portion is grade separated intersection. So what are the basic requirement of intersection at grade? So the basic requirement of at grade intersections are the area of conflict should be small as possible. Conflict area means where that merging, diverging and crossing conflict will occur. That area should be lesser as possible. The relative speed and angle of approach of the vehicle should be small. The speed of the vehicles which is approaching the intersection should be relatively lesser. Why lesser? If the lesser speed would be less, in that case it would be better to control the vehicles and therefore you can avoid the major accident. And angle of approach. What is the angle of approach? Suppose this is the main stream, another vehicle is coming from this direction. Now this angle is angle of approach. Okay. Now as the angle of approach increases, so this will gradually transform into a crossing conflict. Okay. And as it would be minimum, in that case, ultimately it will mixed with the existing traffic. So therefore, your aim should be always to minimize the angle of approach. Then sudden change of path should be avoided. It should be enforced in such a way that the vehicles cannot change their path suddenly. Geometric features like turning radius and width of pavement should be adequately provided, because in the intersection there are chances of conflict because and there are chances of reduction of the speed. So therefore the area of the intersection should be more than the adjoining roads. Proper sign should be provided if the signals is manually controlled. That is, manually controlled means traffic police will control this, or if it is a signalized intersection, in such cases particular in some particular approaches there should be stop signs or other signs that should be adequately visible. Then good lighting at night is desirable, okay, for the better visibility. Now this at-grade intersection may be classified into these groups. First one is unchannelized intersection, then channelized intersection, and another special type is there that is called rotary intersection. Now unchannelized intersection is those intersections which are plain intersection, no channelization would be there. Channelization means that traffic median or traffic separators or traffic island, this type of things will not be provided in the unchannelized intersection. Unchannelized intersection is like a plain intersection. This is the lowest class of intersection. Let me give one example of the unchannelized intersection. See, these are the unchannelized intersection. Okay, they are only the plain road with the intersection. They are unchannelized intersection. So in the unchannelized intersection, there are two types. One is plain unchannelized intersection and another one is flared unchannelized intersection. In the flared unchannelized intersection, at the approaching of the intersection, the width of the road would be more. Okay, these are the unchannelized intersection. Now what are the channelized intersection? These are the channelized intersection. Okay, see here, channelizing islands are provided to manage the traffic. Okay, these are called channelizing island, and it acts as a traffic median or traffic separators. These are channelized intersection. So these are the lowest class of intersection. It is easiest in design but very difficult in traffic operation. And unchannelized intersection you can design only at the case when your traffic volume is very much lesser for that intersection. Now there are different forms of unchannelized intersection like T, cross, staggered. So these are based on the shapes of the intersection. You just go through this note. There is nothing to discuss. Now these are the different type of conflict, that is merging, diverging and crossing conflict, which we have already discussed. Another type of conflict is waving conflict. This is the waving conflict. Now coming to the next portion, channelized intersection. So this channelized intersection are those intersections where channelization is provided, and by providing the channelization, you are basically enforce all the vehicles to follow a particular lane or particular path. So in such a way, so that the conflict point would be reduced. So these are the channelizing intersection. So the advantages of the channelized intersections are vehicles can be confined to a defined path. Okay, so all these vehicles are forced to move in a particular direction. So if any vehicle wants to move in this direction, he cannot go by this. Okay, he always have to follow that particular path. So in this way, you are regularize the movement of all the vehicles. Okay, therefore, the traffic management in the channelized intersection is better than the unchannelized intersection. So, as an example of the channelized intersection, your Naringi-Tinali is a channelized intersection. Now, the channelizing island provide proper place for installation of signs and other traffic control devices. So here you can install some signs. In the Naringi Tinali, you can see that some traffic signs are provided over this area. Okay, like distance of different places are installed over this area. Okay, one post is there. So this type of intersection can be useful to install different traffic signs. Then refuge island can be provided for pedestrian within the intersection area. Suppose what pedestrians want to cross the intersection. So suppose here the vehicle movement is stopped. So the pedestrian can cross the area and stop over here and looking for the opportunity to cross that portion of the road. So this island can be used as a refuge for the pedestrians. So both the major and minor conflict areas in the intersection can be greatly reduced. So by providing the channelization, you can minimize the major conflict like crossing conflict. Angle between desired stream of traffic can be kept as desired in the favorable way. Angle between means angle of approach can be reduced in the channelized intersection. Angle of marching stream can be forced to be at flat angles. Again, the angle of approach for the marching vehicles can also be reduced in case of channelization, and speed control can be achieved over vehicles entering the intersection. So here speed control can be achieved how? Because suppose these vehicles are coming over there and it wants to go over there, so he have to go has to go in this way, then again he has to rotate that rotary intersection, and after that he can go in this direction. So by going like that, by going in a circular motion, the speed of all the vehicles are forced to reduce in a particular amount. Now some basic terminology. So first one is uncontrolled junction. This is uncontrolled junction where no island, nothing is will be there. These are called uncontrolled junction. There will be no traffic police, no signals. Okay, this is a plain intersection. This is called uncontrolled junction. Then priority junction is, suppose in the uncontrolled junction, what happens? This is also a major road. This is also a major road. This is also a major road. The width of these two roads would be same. But in a priority junction, what happens? Suppose this is a major road, okay, of a greater width will meet with a minor road with a smaller width. Okay, this is called priority junction. Then space sharing junction. Space sharing junction means where at a particular place of the intersection, all the vehicles of different streams will share a particular place. This is called space sharing junction. For example, rotary intersection. So in the rotary intersection, like Naringi-Tinali, what happens? All the vehicles from the different traffic stream or different ways will meet at a particular rotary island and they will move around that intersection. Okay, this is called space sharing junction. Then another one is time sharing junction. Time sharing junction means operated by traffic signals. Okay, there will be traffic signals and benefits would be it will control the traffic flow automatically and reduce the conflict in the junction, and it is safer for pedestrian also because when the in some traffic signal some pedestrian signal would be there where the pedestrian can crosses the road whenever the signal is green for the pedestrian, and it uses less area compared to roundabout or rotary intersection. Is it clear? Okay. Okay, so this is the second portion of the intersection design. So in the previous portion, we have discussed about the at-grade intersection. Now coming to the grade separated intersection. So grade separated intersection are those intersection where two or more roads meet at different elevation. For example, your 6 mile intersection where one intersecting road is above the main road elevations. Okay, this type of intersection is called grade separated intersections. Now this grade separated intersection is the most expansive type of intersection. Now why this grade separation is necessary? Okay, on high type facilities like expressway where the speed reduction is not always a welcome thing. Okay, on a high type expressway, like for example a expressway is such type a road where you have to maintain a minimum speed. Okay, otherwise it cannot be called as an expressway. So in expressway, to make the movement of the vehicle easier, in such cases you can design that grade separated intersection where you have to maintain a speed of like 90 km/h. Okay, so in such type of high facilities, you can provide the grade separated intersection. At a place where at-grade intersection have reached its maximum capacity. Okay, suppose one particular intersection is there and it cannot manage the traffic properly. You can observe that in most of the cases, there exist traffic congestions. So in such cases, you can provide at-grade intersection. At location of bad accident history, suppose a particular intersection area is there and because of the different features of the intersection there occurs different accidents and this area is a major accident prone area. In such cases you can install a grade separated intersection Then at junction where the traffic volume is heavy, that is the number of vehicles exceed the limit of the intersection. In such cases, you can provide the grade separated intersection. At certain specific rolling or hilly topography, suppose in a hilly topography there is no place for the at-grade intersection. In such cases, you can provide the grade separated intersection. Then road crossing has 4 through lanes or more. Suppose a road crossing has 4 intersecting road or more intersecting roads, where the management of the traffic would be very much difficult if you provide a at-grade intersection. In such cases, you can provide grade separated intersection to manage the traffic properly. Now there are different type of grade separated intersection. First one is 3-leg design. These are the 3-leg design. Okay, this is 3-leg design. So how the movement of the vehicle would be over there? So the movement would be like that. This portion is below or above this portion. So whenever a vehicle wants to go in this lane, he have to go this way, in this way. Okay, so this is your 3-leg design. Then this is called 4-leg design. Okay, this is 4-leg design. So see, this is the major intersecting point. This is the major intersecting point where these two roads are not at a same elevation. They are at different elevation. Okay, this is 4-leg design. This is called diamond interchange. Okay, this is called diamond interchange. This is actually a road which is above these two roads. Okay, at different elevation from these two roads. This is diamond interchange, and this type of portion is called clover leaf. Okay, this is called clover leaf. There are different shapes of clover leaf. So basically, this type of portion is called clover leaf. Then another type is rotary design. In the at-grade intersection also there are rotary intersection. In this case also there are rotary design. See this picture. Okay, this is a practical picture from some places. This is called rotary design. Now another type of intersection is called rotary intersection. This is a special type of at-grade intersection. And this is essentially in the rotary intersection, all the major conflicts at an intersection, namely the collision between throw and right turn movements, are converted into milder conflicts. So in the rotary intersection, what happens? All type of crossing conflict will be converted into merging conflict or diverging conflict by reducing the angle of approach. Okay, therefore you are reducing the potential conflict at the rotary intersection. So basically this is the advantage of the rotary intersection. Now the vehicles entering the rotary are generally forced to move in a clockwise direction in a orderly fashion. Clockwise direction means they need to follow the path, or they need to go around the rotary intersection. Then they wave out of the rotary to the desired direction. Wave out means then they diverge to their original path which they have to follow. Now there are different advantages of the rotary intersection. Now these advantages are: first one is traffic flow is regulated to only one direction of the movement, thus eliminating severe conflict between crossing movements. So all the vehicles are forced to move around the rotary, so therefore they have to follow a particular path, and in this way you are reducing or eliminating the number of conflicts over there. Next one is all the vehicles entering the rotary are gently forced to reduce the speed. Why reduce the speed? Because they have to follow a particular path and go around the rotary. So in this way, they are forced to reduce their speed. Because of the lower speed of negotiation and elimination of severe conflict, accident and their severity are much less in rotaries. Why? Because the speed of all the vehicles are reduced. Okay, therefore, you are eliminating the chances of severe conflict in the rotary intersection. Then rotaries are self-governing and do not need any control by traffic police or traffic signaling system, and they are ideally suited for moderate traffic, especially with irregular geometry or intersection with more than 3 or 4 approaches. In such cases, you can, for the moderate traffic, you can provide the rotary intersection. Now, there are some disadvantages of the rotary intersection. First one is, if there is less number of traffic also, in that case also the speed in the rotary intersection is relatively lower. All the vehicles are forced to slow down because of the rotary intersection and negotiate the intersection. Therefore, the cumulative delay of all the vehicles would be more. Cumulative delay means delay caused by the rotary intersection, that would be very much huge comparing to a plain intersection. Then rotaries require large area to construct. Now in the urban area, this large area may not always be available. Another thing is, the vehicles do not usually stop at the rotary. They accelerate and exit the rotary at relatively high speed. So think about whenever you are driving through a rotary intersection, what happens whenever you are approaching the rotary intersection? In that case, your speed would be reduced. But what happens after some times when you are about to exit the intersection? In that case, you increase your speed and just exit the intersection. So if there are high number of pedestrians in your exit path, in that case, it would cause some problems for the vehicle movement as well as the pedestrian movements. So if there are high number of pedestrians for a particular area, in such cases, this rotary intersection will not be suitable in that area. Now, guidelines for the selection of the rotaries, there are different guidelines. Now, rotaries are suitable when the traffic entering from all the 4 approaches are relatively equal. If all the roads are major intersecting road, in that case, rotary intersection would be ideal. A total volume of 3000 vehicle per hour can be considered as the upper limit case, and a volume of 500 vehicle per hour is the lower limit. Suppose a plain intersection is there and you want to check whether you can install a rotary intersection over there or not. So for that reason, what you have to do, you have to go for the traffic volume study. Now, if you found that your traffic volume is more than 500 vehicle per hour, in such cases, you can install the rotary intersection. Now, if it is more than 3000 vehicle per hour, in such cases, you cannot install the rotary intersection over there because the rotary will fail. Okay, in such cases, what you have to do? You have to go for the grade separated intersection. A rotary is very beneficial when the proportion of the right turn traffic is very high. Typically, if it is more than 30%, right turn vehicles means the vehicles are moving in the right directions. For example, so basically these are the right turning vehicles. Okay, these are the right turning vehicles. Now, if the proportion of this right turning vehicle is more than 30%, in such cases, you can install the rotary. Now, rotaries are suitable when there are more than 4 approaches, or if there is no separate lanes available for right turn traffic. If there is no separate lane for the right turn traffic, in such cases also you can install the rotary intersection. Now, if the geometry of the intersection is complex, In such cases, you can install rotary intersection. Geometry is complex means suppose this is one road, this is another road. Okay, suppose all these road are meet so you can provide a rotary intersection over there if the traffic is moderate. Now, if the traffic is high, in such cases, you have to go for the grade separated intersection. Now coming to the next portion, design elements of the rotary intersection. So first one is design speed. So first let us discuss about different component of the rotary intersection. This is called the central island. Okay, this is called central island, and these are different approaching road. These are different approaching road. Now if this is channelizing island, okay, so this width from this channelizing island to this width is called entry width, and this is called exit width. Okay, entry width, exit width, and for all this lane, entry width, exit width, like that, entry width, exit width, like that for all this road. From this your traffic island to this traffic island, this total length is called waving length. Okay, this total length is called waving length. This is called approach width. Okay, this is approach width. This is approach width, and this is entry width. Now first one is design speed. So all the vehicles are required to reduce their speed at a rotary. Therefore, the design speed of rotary will be much lower than the roads leading to it. So if this is a rotary intersection and these are the approach lane or approach road, in such cases what will happen, the design speed over here would be more than the design speed over here, because in the rotary intersection all the vehicles are forced to reduce their speed. Therefore there would be differences in design speed in the intersection area and in the main approaching roads. Although it is possible to design a roundabout without much speed reduction, the geometry may lead to very large size, including huge cost of construction. Okay, as you increase the waving length, if you increase the waving length, in such cases you can increase the speed. But to increase the waving length, you again have to increase the radius of this area and this total area. Okay, so therefore it will include huge cost associated with it. Now the normal practice is to keep the design speed as 30 and 40 km per hour for urban and rural roads. So for the urban roads, the intersection would be so the speed at the intersection would be limited to 30 km per hour, and in the rural area it would be 40 km per hour. This is the limiting speed, keeping in mind that is the speed based on which you have to design your rotary intersection. Then coming to the next, entry, exit and island radius. So this is the entry radius, okay, this is the entry radius, this is the exit radius, and this is the island radius. Now the radius at the entry depends on various factors like design speed, super elevation and coefficient of friction. Why super elevation? Because this is a curved area, so therefore super elevation would be there, and based on the super elevation and your coefficient of friction, therefore other factors will come in with the super elevation. The entry to the rotary is not straight, but a small curvature is introduced. That's why it is called entry radius. This will force the driver to reduce the speed as they have to go in this way, therefore their speed will be reduced. The speed range of about 20 km per hour and 25 km per hour is ideal for an urban and rural design respectively. This is ideal condition, and the previous one is your limiting condition. Now the exit radius should be higher than the entry radius and the radius of the rotary island, so that the vehicles will discharge from the rotary at a higher rate. Okay, here your entry radius should be higher than the exit radius and waving length, so that the vehicle entering the intersection could be go at a higher speed when they are exiting the intersection. So whenever there will be a huge number of pedestrians, in such cases you can design the entry, exit and radius of the circular portion as similar. So in such cases what will happen? The speed at the entry and speed at the exit will be same. Therefore, in the exit portion, there would not be higher speed for the vehicles, and thus you eliminating any chance of conflict with the pedestrians. Now the radius of the central island in practice is given slightly higher reading, so that the movement of the traffic already in the rotary will have priority of the movement. So if you are increasing the radius of this, in such cases what will happen? You can accommodate much more number of traffic over this area, and it will be beneficial for the rotary intersection. The radius of the central island, which is about 1.3 times that of the entry curve, is adequate for all practical purposes. So you can install different features over there, different signposts or other things over there that is visually attractive things, your arts and cultures, something like that you can install over there. Okay, so our class will be ending in 5 minutes. Okay, please rejoin the meeting. I'm ending the meeting and again you have to rejoin.